So we just got through all the packet walks through DRs and SRs and tier 0 and tier 1 gateways and all kinds of stuff, right? Where do the packets go? Let's wrap up this series with a discussion about VRF Lite. And we wrap this up, we tack this on here at the end of this series because it's just going to kind of augment things that we have looked at to this point, right? So it's a feature that we introduced, back about NSXT 3.0, somewhere in there, that gives us the capability to kind of carve up our tier 0 gateways into smaller virtual routing and forwarding instances, giving us similar functionality to a tier 0 gateway without having more tier 0 gateways, right? That's really what VRF Lite is all about. And this is going to be potentially a big resource saver if you maybe need a bunch of different tier 0 gateways for one reason or another. Now, what do we need to make this all go? Well, I have to have a tier 0 gateway, which means I need everything that a tier 0 gateway requires, right? My edge transport nodes. I need NSX to be installed. I need my transport zones to be set up, all that kind of stuff. I need set and my tier 0 gateway built before I can build a VRF instance. I'm also going to have some kind of, at least one external peer dedicated for my VRF. This could be a VRF on a physical device. It could be another physical router altogether. But this is going to be some separate device than maybe what I'm peering with on my parent tier 0 gateway. That device, that upstream device, whatever I'm peering to, has to support 802.1q. It has to support VLAN tagging because we're going to send from our VRF uplinks VLAN tagged frames, right? So the destination peer has to understand how to deal with those VLAN tags. And here we kind of see what VRF Lite brings to the table. When we look at what we've got going on, when we look at how I might build up 3 different tier 0 based routing domains in NSX, that means I need at least 3 edge transport nodes, right? And that it may go further and it may mean that I need 3 edge clusters and 3 sets of edge nodes. Where with VRF Lite, I could consolidate all of that networking, all of those independent routing domains. I could consolidate that onto a single edge node if I so desired, or perhaps a single edge cluster might be a more reasonable way to approach it. But it allows me to consolidate resources. Now, does that mean that, I still get the overall throughput of 3 distinct tier 0 gateways on 3 distinct edges? No. This would be useful in a case where maybe I need routing domain isolation, but I can deal with a little bit of network oversubscription because maybe none of the routing domains will saturate, that 10 gigabit virtual NIC on the edge, something like that, right? So I'm going to think about where these go in my infrastructure, where I might need to reduce my resourcing footprint, and these just become another great tool in my toolbox. With VRF Lite, we can support both single tier and multi-tier topology. There's nothing unusual about that, I don't think, but I can support the same topologies hanging off of a VRF Lite as I can just off of a tier 0 gateway. My interfaces on a VRF Lite, I've got the same interfaces as well. I've got uplink interfaces, I've got downlink interfaces, so I can attach segments directly to for my single tier topologies perhaps. I have my router link interfaces, I have my intra-tier DR to SR interfaces. Every VRF instance comes with its own DR and its own SR component, right? So they've got their independent components in the infrastructure. Now, we talk here about VRF control and data planes, and these are not necessarily to be confused with the control plane and the data plane that we look at inside of NSX, that we attach to to software-defined networking as such, the way we do in NSX. What we're talking about here is kind of meeting your network engineers kind of in a place where they're comfortable. When we talk about things like VRFs and connecting to whatever it might be, maybe an MPLS gateway or what have you, right? We're going to talk about using things like BGP for the control plane. We're going to talk about using VLANs for the data plane. What we're talking about here is really the connectivity and the management of that connectivity, the management of the routing between the VRF instance and its upstream peer. Now, how do we configure VRF Lite? Well, we start off with something that I think is pretty familiar at this point, and that's configuring and setting up a Tier 0 gateway. All right, that's our first couple of tasks here. We get into step 4 of this diagram, and we talk about building uplink trunk segments. And these are just going to be VLAN segments that we build in NSX, much like we built for our Tier 0 gateways. But we're going to create these as trunk segments, meaning that we're going to assign more than one VLAN to these uplink VLAN segments, right? So that we have trunks where we can carry different VLANs from the different uplinks on the VRFs. Then we're going to deploy a VRF gateway. We saw that if we paid attention when we deployed our Tier 0 gateways, right? I had a drop-down menu that said deploy a VRF instead of a Tier 0. I'm then going to configure the uplink interfaces on the VRF, right? So I'll configure the uplink interfaces to use those trunks, and then I'll set up the rest of the VRF. I'll set up its own, the BGP peers and all that kind of stuff on the VRF, and then finally we will attach a Tier 1 gateway or downlink segments and consume that VRF for routing purposes. So deploying the Tier 0 gateway, just a recap here. We've seen this already. Under the networking view, I go to the Tier 0 gateways, and in the drop-down, like I said, I select a Tier 0 gateway, and I create it up and I configure what I need to configure. That will include configuring probably uplinks. Now, if a Tier 0 gateway has VRFs attached to it, that doesn't mean I still can't use the Tier 0 gateway, right? The Tier 0 gateway becomes another router that I can use alongside the Tier 0s. So I'm going to configure my Tier 0 gateway and configure its uplinks, and I'm going to set up BGP. Now, this is important because many of these BGP configurations are global parameters, right? Meaning that they're going to be used and inherited by or perhaps I should say that the other way around, inherited by and used by the VRFs, right? So the autonomous system number, graceful restart configurations, multipath relax, things like that. These are all things that I cannot change on a VRF instance. So I have to manage those from the parent Tier 0 gateway. Then I need to build my uplink segments. And this is just like we built our segments earlier. The difference here for the uplink segments is for the uplink trunk segments, I simply assign more than one VLAN. Now, this will be however many VLANs I have transiting for my different VRFs, however many that's going to be. We're going to use 2 here, but you can use however many is appropriate for your infrastructure. Then we're going to go back to our Tier 0 Gateways UI and hit the Add drop down. And instead of a Tier 0 gateway, this time we're going to select VRF. When we configure the VRF object, we give it a name just like we would any other gateway. We have to select the parent Tier 0 gateway, right? And when we select the parent Tier 0 gateway, we're going to automatically inherit the edge cluster location and the HA mode. So I can't have an active gateway with an active standby child VRF. That's not something we're going to be able to do. So I've got that I can think about, but those are things that we're going to inherit from the Tier 0 gateway as well. Then I go in and add my interfaces, and I'm going to set my interfaces and create those interfaces as necessary. This is almost the same as creating uplink interfaces on a traditional Tier 0 gateway. Difference here is going to be that we're going to attach to that trunk segment first off. And secondly, we have an access VLAN ID field that we have to populate. That access VLAN, right? That's the VLAN we're going to tag packets egressing the VRF with. So we need to make sure we set this and that VLAN ID exists as part of the uplink trunk segment configuration that we did a minute ago. Then we need to configure BGP, right? OSPF is not supported as a routing protocol for our VRF instances, right? BGP is the only dynamic routing protocol that we can have. So we're going to bring together the configuration. We can enable BGP, or we can not. We can support static routing only if we need to. We cannot support inter-SR BGP on a VRF like we can on a Tier 0 gateway. So that's not going to be available to us. That's not something I can toggle. Here again, we mentioned that multipath relax and graceful restart configurations are inherited. My local autonomous system number is inherited. So I can either enable or disable BGP, and I can set my neighbors. And so I'm going to build my own BGP neighbors unique to this VRF, right? Whatever my upstream peers are, I'll configure them just like we did when we built our BGP Tier 0 gateway. And there we go, right? Our uplinks are there. Our BGP neighbors are there. We've got a configured VRF. To use that VRF, I can simply change the Tier 0 gateway attachment. So I can move my Tier 0 gateway, or my Tier 1 gateway, my Tier 1 gateway from maybe a Tier 0 gateway over to a VRF, where I can create new gateways altogether. Validating a VRF is pretty straightforward. I look at the status. The status should tell me that we are successful. If I click on the status field, it's going to bring up a transport node by transport node view where I can look and see if there are any transport nodes individually with problems. We're talking about the edge transport nodes here, any specific errors that we might see. This is a valuable thing to look at. So VRFs are an awful lot like building Tier 0 gateways. And we're going to see that here in the lab. Now, this lab's going to take us just a few minutes because what are we going to do? We're going to set up our trunk segments. We're going to deploy a couple of VRFs, 2 of them. We're going to create 2 new Tier 1 gateways for our VRFs. We're going to connect those to the VRF. We're going to create a couple more segments, right? We'll have our VRF red and VRF blue segments that we create. We'll go ahead and attach those to the Tier 1 gateways that we created in Task 4. Then we're going to put some virtual machines on those 2 segments. We're going to test connectivity. We're going to look at routing tables. Then we're going to validate that we are indeed in isolated routing domains. So there's a lot of stuff going on in this lab, a whole lot of stuff. But it's worth it. It's absolutely worth it. Take a couple of minutes, go through this lab. When you come back, we'll go ahead and wrap up this video and this entire section. All right, we've made it through VRF Lite. So what did we look at? We looked at how VRF Lite is there as kind of a resource consolidation mechanism, as well as a potential routing isolation mechanisms. Really, really great stuff. Now, what else have we talked about? This has been a long series of videos, hasn't it? We've talked about logical routing, why we have it, what we have. We've talked about our Tier 0 and Tier 1 gateways. We talked about how we have to have edge transport nodes that are built into edge clusters. We've talked about edge high availability and how that's going to detect everything that's going on, right? Detect when we need to fail over. We've talked about different ways to deploy the edges, bare metal or virtual. We talked about BGP and OSPF and configuring all of that. We have come through quite the routing journey here. And now it's done, right? Now you should have a fairly solid understanding of the basics of what NSX can do in routing and in logical routing. And that's about that. Coming up next, we'll talk about logical bridging. So come back for the next video. I can't wait to see you there.